Now, since when the official answer key for GATE 2021 mechanical is out, many of you students have mailed me to discuss a specific question from casting that was there in set 1, right? So that's what we are going to do in this video, whether you should challenge that question, whether you should challenge the range of the question, what logic you should give, what concept you should give, what source you should quote there. I am going to discuss all of that in this video. So make sure that you just listen to me carefully till the end and everything will be clear to you what needs to be done. Alright, let us first have a look at the question first. I'm sure you have gone through the question. Just have a look at the question once again. And the point of discussion in this question is the diameter. Whether you have to take the outer diameter of the casting or the mean diameter of the casting, right? Now, official answer key has considered the outer diameter for the calculation, okay? If you solve it using mean diameter, your answer will not be in the given range of the question, okay? The thing is that to challenge the range or to challenge the answer, you need to refer to some source, some standard source, standard books that IITs will admit, right? If you have some sources over the internet, which are some sources which IITs might not recognize, there are some journals and such books and sources which IITs will not recognize, then it will be a waste of time and effort to challenge it, right? So whether you should challenge, and if you want to challenge, how you should challenge, that I will discuss here. Look, in this case, to teach this specific topics, even the IIT has used a standard book. The screenshot of that you can see here. This is the screenshot from NPTEL content of IITs. This formula you can see here, where they have taken inner radius of the mold, which means outer radius of the casting for calculation. You can also see the source from which they have taken this, MP Grover 4th edition. It's a standard book. Now, since NPTEL content of IIT has referred this book to use this expression directly, and if you want to challenge this question or you want to challenge this range, it would be best to refer to the same source that they have used. Refer to the same book, the 2nd edition of that book, chapter number 11, problem 11.7 part B. I am sharing one screenshot of that here. Have a look at the calculations. In the calculations, just focus on two things right now. Only two things you need to focus upon. This expression V is equal to pi d n by 60 or pi r n by 30. What expression of radius or diameter is getting used? The mean radius is getting used. This is first conclusion that you can draw from the same book which the NPTEL content has referred to. Second conclusion, that to find out the centrifugal force on the inner surface of the mold, the same surface which is same as the outer diameter of the casting, even for that the centrifugal force is mv square by r, where r is again the mean radius, right? These are the two conclusions that you just need to take away from here. I am not discussing it conceptually yet. I have not discussed that. I will discuss that using the derivation from the same book, but right now just have a look at these expressions, that both of these expressions are going to be used in the derivation, and both of these expressions in the same source in a question where the force was required on the inner surface of the mold, which is same as the outer surface of the casting. Even for that also, the centrifugal force and the velocity are using mean radius for the calculation. Let us now discuss this question. Have a look at the derivation of this question from the same source which NPTEL has referred. So these two conclusions of mean radius I have encircled here. Alright. Let us come to the expression that we have used to solve this question. This is the casting that we have to cast. This is the inner diameter of the casting, inner radius of the casting, outer radius of the casting, and outer radius of the casting is same as inner radius of the mold, right? Because the outer surface is pressing against the mold, the circular shape, the cylindrical shape of the mold. That's what I have written. RO, which is outer diameter of the casting, is same as the inner diameter of the mold, right? Now, the expression that we use to find out the rotational speed, I am taking that directly from the same source which NPTEL has referred to. Okay, this is the derivation of that, and I will keep showing you the screenshot of the same book, the fourth edition of the same book. I am sure derivation is same in all the different editions of the same book. The thing is that the first statement that they have used to find out the centrifugal force, what they have written, centrifugal casting is defined by this physics equation. This casting, this molten metal which is pressing against the mold is undergoing a centrifugal force, right? That centrifugal force is ensuring that it is sticking to the surface of the mold. That centrifugal force which is felt by this particular casting, mass we are taking of the same casting. Please don't think that we are taking mass of the mold. We are taking mass of the casting, that part which we are ultimately casting from the molten metal. So that mass we are using here. Alright, so if any of you thinks that mass of mold we are taking, so we should take the radius of mold only, that is not the concept here. So for the centrifugal force that this casting, this mass is experiencing, we are using a value of radius which according to this source is derived from physics, but the source has taken this radius to be outer radius of the casting or inner radius of the mold. Now look at this physics problem. You have a problem from physics where there is this cylindrical body. You have to find out the centrifugal force on this axially rotating cylindrical body, which will be given by roughly mv square divided by r. R value will never be equal to the outer radius. You can integrate and check yourself. Obviously in this case, to find out the centrifugal force, we have to perform a small integration, right? If you perform that integration, the value will come, especially for thin cylinders, almost the same as the mean radius. It is nowhere equal to the outer radius, right? No physics equation, you can search any text on physics, no physics equation will tell you that for such a cylindrical casting rotating about its central axis, mv square by r will be equal to outer radius, right? So point number one, it's a contradiction from the physics. The same source is quoting this physics equation which you cannot find in any physics text, that mv square by r is equal to, where r is outer diameter of the casting or inner diameter of the mold. Point number two, this is contradicting in the same source. I have already told you problem 11.7 part B, where this equation is used, where r is used as mean radius. Point number two. So these are two contradictions in the same text, right? Let me tell you what would be the most logical way to proceed from here. The cylinder that we are forming, generally the cylinders that we form, they are thin cylinders. We already know how we define thin cylinders, right? The thickness of the cylinder should be less than 7% from the inside radius of the cylinder. This is the same definition that I am quoting from roughly the same source and the NPTEL. Okay, so I am not going in any other random sources. You can go and check yourself. The thickness, as far as I can remember, the two values we have been given in the question, 230 inner dia, 250 outer dia. So thickness is 10 on each side, which is very less than 7%, half of that roughly. So it definitely is a thin cylinder that we are discussing in the question. Even for this discussion also, if you conclude that it's a thin cylinder that we are discussing, so there will not be much deviation in the outer radius or outer dia and the mean dia. This is a logical conclusion that we can make here, that since the mean radius value we have to calculate from inner and outer value, but directly taking the outer value of the casting or inner dia of the mold is known to us, it is given to us. Whenever you are doing a casting, you already know the inner diameter of the mold, right? So this is a value which is known to us. So rather than calculating it for every casting, since it will be a thin casting, we can assume that the mean value and outer value are going to be nearby. So let us take inner value of mold here or outer value of casting here. This is the most logical conclusion that we can draw here. That how can we contradict physics equation on this criteria, that both these values are very near to each other. So it is easier for us to just assume that mean and outer value are going to be almost same. So let us use the outer value of diameter of casting or inner dia of the mold, right? Only then you can say that this equation you can write. So let us assume that this question at this point, this expression at this point has taken the outer dia of casting to be almost same as the mean dia, because the casting that we do here are thin. Specifically, you go back and check the values. The question that we have been given is a thin cylinder. So there you can say that both the values will be very nearby, within plus minus 5%. So we can do that. Now moving ahead, the G factor is defined as the ratio of centrifugal force to the weight. The centrifugal force has used directly this expression of R, which is the outer radius. Now ultimately when you solve it, M and M will cancel, you will get V square by Rg. Again you have used the expression V is equal to pi R n by 30, where R you have taken as outer diameter. Now again it's a clear contradiction. If you have this tangential velocity, if I show you the variation of tangential velocity, in such a case, it will be a linear variation like this, right? Because V is equal to pi R n by 60. N is same everywhere, pi and 30 are constant, R is varying linearly, right? So velocity, tangential velocity will vary linearly with the radius, right or not? We have inner as well as outer radius present. In such a case, what radius will you take? Mean radius. You can go and check any source on physics that says that in V is equal to pi R n by 60, R will be outer radius. You will not find even a single standard source which says that. Even in the same source, in the question, to find out the velocity, they have used mean radius. Problem 11.7. Again I am repeating, part B of the question, second edition. It is very much logical that this expression here cannot have outer radius, right? That will tell you only the outer velocity, right or not? So by concluding from these two, this expression has come where R they have taken to be the outer radius of the casting or inner radius of the mold. So this derivation basically is not something different. This derivation only uses two expressions. First expression, second expression, both of them, we know it from the physics that both of them are incorrect. The same source has used them as mean value in different questions, but in this question, IIT has given the answer based upon the outer radius of the casting or outer dia of casting or inner dia of the mold. This is the problem of this question. Now, let me tell you what way you should use here. To challenge this question, if you have any, I have because seen different sources which even students have shared with me, that sir, in this journal, in this book, it is taking the outer diameter of the casting. But don't quote any such sources which are not considered standard by the IITs. Because if you will send them any PDF, any books link which they don't consider a standard source, then they are not going to use it. They are not going to accept it. So the best way for you in this case would be that if you have got the answer correctly, you have got the outer diameter, that is correct, there is no issue in that. I am telling you why. Because from the questions point of view, IIT use these standard sources directly, right? If you ask them to check by solving questions, it is something that they won't be interested in doing, obviously. And this is something that I told the students of Exergic already, that if there is any such confusion, take the outer dia. From specific marks point of view, IIT will stick to outer diameter only. This is a screenshot from the discussion that I did in the premium group of Exergic before GATE examination. But let me tell you the solution here. The outer diameter, since it is referred directly in this source which IIT has referred, their answer is correct. Obviously, if it has mentioned in a source which IIT is considering a standard source, they cannot reject the outer diameter. But mean diameter should also be in the range of that specific question. The reason I have told you here. What you have to do, let me tell you. Don't focus on any random source which is quoting outer diameter but it is not recognized by IITs. You have to quote the same book. Chapter number 11, problem 11.7, part B. The question has used V and FC using the mean radius. Point number 1. Now quote the same book, and in the same book, in the derivation, you can quote this statement from the physics equation, Fc is equal to mv square by r, where r they are taking as outer radius of the cylinder. it is not verified by any physics source. You can mention any standard physics source, or it is something that I don't think IITs want to see, that no, mv square by r, the r value can be outer also. I'm sure everybody is aware of that. So you can refer directly that this equation, which takes the value of r as outer value, is assuming what you have to write, that I am telling you. This equation is assuming outer dia to be same as mean diameter. This is something that you can definitely write, because not only the centrifugal casting is used for thin cylinders, but the question that has been given to us, it has a thickness merely of 10 mm or centimeter, whatever is given in the question, and inside radius is 230 centimeter or mm, whatever is given in the question. So you can check the percentage, around 4 to 5% it will come, which is less than 7%. It is a thin cylinder. So you can mention that the given question was having a thin cylinder where this assumption is used that outer dia is same as mean dia. On the basis of that, this radius is taken as outer diameter directly. But does it mean that mean diameter will become incorrect? No. Both of these values you have interchanged only because both of the values are very close to each other. If they are very close to each other, in the derivation itself it has been replaced. The range of the answer should also consider both of them. There is no conceptual or logical explanation that can be given here that no, outer diameter will only come. Only convenience that we know the value of inner dia of the mold, let us use it directly on the assumption of outer dia same as mean dia, we are using here. So for this specific question, which is a clear case of thin cylinder, both the outer as well as mean value should be within the range. This is what you need to write when you are challenging the question. I have mentioned the sources also, the same source that NPTEL has referred to. You can mention the physics equation also, and you have to mention this assumption also that outer dia almost same as inner dia is used in the derivation of this particular expression itself. So both the values of, outer dia is equal to mean dia, not inner dia. So this assumption has been used in the derivation of this expression, which means that in the answer also, mean as well as outer, both these values should get you the answer within the range. So ask for modifying the range of this question, because this is something which has the most probability of happening. Let me tell you very clearly couple of things here. Every year there are such cases, 1-2 questions which conceptually are correct, but still they are not accepted by the IITs. It happens every year. Although if we compare it with other exams, the system that IITs have made, the gate and all challenge system, is way better than other exams, but still every system has some flaws, right? So in this challenge system also, there is no guarantee that IITs will accept whatever modifications are even conceptually correct, right? But still, those of you who are going ahead to challenge this question, do it only for the range, do it only to include the mean diameter using all the concepts and sources that I have mentioned. And again, I am telling, there is no guarantee that these are going to get accepted, right? It depends every year, it changes every year. Different IITs conduct exams every year. The body that reviews it keeps changing every year. So you can try if you want to do, but it is my advice to be practical in this approach, and even if it is not accepted, you should be ready for that.